You passed that recording.
Body temperature. The normal body temperature range is 36 to 38 degrees Celsius. And so when your body temperature gets above that, you can get into a situation where you're experiencing heat stress. And there's three main areas that can impact your personal body temperature. The first is the environment. So what's the air temperature around you, the humidity, radiant heat from, say, hot asphalt or like equipment that may be adjacent to you. You could also just personal factors such as like how well hydrated are you? What's your, do you have any existing medical conditions? Are you used to the heat, or is this like the first hot day of the year? And what kind of clothes you're wearing? And then finally, what type of work you're doing. So are you doing light duties where you're sitting at a desk, or are you outside doing heavy construction work and not getting any breaks? So those are kind of the three areas that can impact your potential to have a heat stress issue. So we are required under our provincial legislation to have exposure control plans for various risk factors that workers might experience. And so we are required to have an exposure control plan for heat that puts efforts in place and actions and controls in place to first minimize the chance of a heat stress incident occurring, and then also giving tools and resources to make sure that people, if it is hot, they have tools and resources available to address those concerns. And then also having a control plan makes us compliant with our occupational health and safety regulations. Our provincial regulations give two ways that we can measure heat stress. The first is the Humidex method. And so it's kind of a simplified method. What it does is on site where the crews are working, they would measure the air temperature, which is in this example would be the 31 degrees, and the relative humidity of the location. And then they'll come up with a Humidex value, which in this case would be 38 in the example I'm showing here. And so every hour on site, you have to measure take those two measurements and come up with this Humidex value. And then it applies a correction factor or adjustment factor for conditions such as the worker and the workload to come up with an adjusted Humidex value. So once you have that adjusted Humidex value, it will look at what type of work you're doing on the column on the left, whether the worker is acclimatized or not, and then it will tell you specific controls that you have to put in place to prevent heat stress or minimize the chances of heat stress from occurring. So this is one of the methods that we use in the city of Vancouver, and it's one of the methods that's provincially mandated. The other method is the wet bulb globe temperature method, and it is more looking at the heat stress on the body. It's a lot more accurate. It's not kind of that simplified where you're just looking at a table and crossing them, getting the two pieces to cross and adding the adjustment factor. So it will take a wet bulb globe temperature reading on site, and then it will add a factor for whatever clothing that you're wearing. And then it will give you a reading, a wet bulb globe temperature reading that you would look to put in controls in place. So it's a lot more accurate, and then it will dictate what kind of controls you need to have in place. So if you're doing light work and it's you get a wet bulb globe temperature reading of 28, you don't need to take any rest breaks. But if you got 28.5, for every hour you work, you'd have to take 15 minutes off. So 75% work, 25% rest. So yeah, as that goes up and up, you have to take longer and longer breaks. And so the wet bulb globe temperature thermometer method is one that you use when we use it often for our crews that are working on asphalt and building roads, because they've got the hot asphalt radiant heat source next to them. We also have the people in our fleet and manufacturing services group using that Can everyone still see my slides?
Yes, yes.
Okay,
We
good.
see the
Yeah.
slides, yeah.
Okay. It's not
Perfect.
showing the same square around them anymore, so I wasn't sure if something happened there.
Yeah.
Let me know if that changes. So in terms of what initiated the improvements, it was really the 2021 heat dome, which I'm not sure if you experienced where you are, but we had in June of 2021, we had about a week where the temperatures were very high for us, and the humidex was also very high. And so in the province of British Columbia, I believe there are approximately 700 people that passed away as a result of heat incidents. We were lucky in that we didn't have any incidents at our work, but it kind of initiate us taking a look at our program and seeing, do we have all the relevant pieces in place to support our workers? And so when we did our review, we found that we had some gaps between our plans and the WorkSafe BC requirements. So first off, we weren't measuring heat conditions on site. So we weren't taking an air temperature reading. We weren't measuring humidity. We weren't doing adjustment factors. We did have some controls being put in place, but they weren't lining up with kind of a methodology for the measurement. And we weren't recording what controls we were putting in place. So we had a number of different gaps that we wanted to address for the 2022 season. To start us on our path for improvements, we ended up setting up a project. So we have a lot of different stakeholder groups. I mentioned before, we've got 1,800 staff, 9 different branches across engineering. We've got our safety team, human resources. Our employees are unionized, so our unions were very interested in the work we were doing to make sure that their members are safe. And then the engineering leadership team, which is kind of our overarching leaders in engineering to kind of guide us through the process. So we did a review of the legislation, our corporate plans, talked to peer municipalities to make sure we knew what they were doing, and also private organizations as well. And we developed kind of a phase 1 and a phase 2 implementation. So the phase 1 was going to be, we had to order hygrometers for the measuring tools. So phase 1 was going to be implemented while we were waiting for our hygrometers to be delivered. And so that was kind of a centralized approach that I'll talk a bit more about. And so using that approach, we came up with these detailed heat responses that addressed each of the gaps I talked about, had the workloads, the adjustment factors, what controls were in there, and we purchased our hygrometers. Unfortunately, 2021, early 2022, there were still a lot of supply chain issues. So we actually didn't end up getting our hygrometers until after the summer season was over. And so we ended up only doing phase 1 in 2022. This is a list of the regulatory requirements that we had to review to come up with our plans. So these are defined by the province, and we have an organization called WorkSafe BC who kind of defines our regulations and then creates guidelines. So any of these documents that have a G in front of them is a guideline that helped us kind of define our plans. Our controls were put in place based on the hierarchy of controls. So firstly, trying to eliminate any potential for heat stress. So we were looking to change hours of work so that workers weren't exposed, or if we had a shift on the weekend, we're trying to cancel that shift and schedule it for a day that is hotter if the forecast was showing us really hot. We also looked to substitute duties. So if there were crews that were working outside, was there potential for them to do work in air conditioned facilities? We also gave crews additional engineering controls like reflective tents. We have these misting stations that hook up to our fire hydrants that spray out a mist. So crews could just get some cool water on them when they're out. We have ice baths, installing additional ice machines in our facilities to make sure there's lots of ice out to crews, and additional air conditioning in vehicles that did not have it. We also did a lot of administration training. So we did training for our heat stress programs. instituting more structured breaks. And we finally got some PPE hats. We have cooling bands and light clothing. We've looked at some things like cooling vests as well, but haven't gone to those yet. So yeah, the phase one approach, because we didn't have the on-site measurement tools, we did a centralized forecasting and activation of plans. So there we have 5 weather stations around the city. So every hour, once the heat got above air temperature got above a certain threshold, a report got sent out for what the humidex value was at these 5 locations around the city. And then that email was sent out to crews, and crews would determine what their adjusted humidex value was and implement the appropriate controls. So if you had a humidex, in the example I've shown, a humidex of 36, if you had a measurement of 36 and an adjustment factor of 6, you would go to an adjusted humidex of 42. And then you'd go over and you'd have this email and say, okay, what you need to do is post a heat stress warning notice, notify workers that they need to drink extra water, ensure they're trained to recognize systems, and then they have options for putting their tent up, a forearm ice bath or hard hat, the shades as well. So it kind of just sends them out the email and they just look up, add their number to the number that's closest to their location, and then they know what to do. Oops, sorry. So yeah, we used that for the summer of 2022. It resulted in us having to do partial shutdowns of our crews of various crews for a couple of days where the temperatures got really hot. And so that led to a little bit of confusion amongst crews because some crews were shutting down and some crews did not. So we had to really look at like, how are we communicating out which crews are shutting down? Are there ways to reallocate crews to other work so that we're not having to send people home? We had to shut the crews down because we didn't have medically supervised work processes implemented. So once the adjusted humidex gets above a certain level, only medically supervised work can continue, and we didn't have practices in place for that yet. So that was something that we recognized we needed to do for future years. We also have groups that work with a radiant heat source. So because we didn't have the hygrometers yet, we couldn't do the wet bulb globe temperature readings. So that was definitely a takeaway. And then just with the central reporting, people weren't sure which location that they were closest to. And it also required a lot of like monitoring. Someone had to be like looking at all the 5 sites every hour and drafting an email and sending it out. So we wanted to switch to something a little more user-friendly and less labor-intensive going forward. So for 2023, we implemented some new improvements to help with that. We got our hygrometers, which was fantastic. They can be used for both the humidex method or the wet bulb globe temperature method. So we have the same device for each. We did develop our processes for our radiant heat groups. And we also developed a new heat stress online tool using the humidex method. So I'll show you a little bit more about that in a couple of slides. And we updated our plans and did some communications to our staff and through our website. And then we also did training with all of our supervisors to show them how to use the temperature devices, how to use the online tool, so that they were prepared for the summer season. These are some pictures of our online tool. So it includes 2 primary features for our leadership and for workers. First, when you go on it, it will give you an idea of what's the forecast coming for the day ahead and how is it looking for temperatures. And then once you know you're getting into a heat stress situation, an email get sent out to say you need to start doing your measurements on site, and then you can enter them into the calculator. You would select the department that you work for, and a lot of those adjustment factors for clothing and pieces will be in there, and they store in there for the next time you use it. You'd enter in the readings. So your worksite temperature on this middle picture was 30 and the worksite humidity was 65. And then it will tell you your humidex reading. In this case, if I use those two measures and it does all the adjustment factors, it would have given me a humidex reading of 43. 43 is quite high for this type of work that's happening. So I'm not sure if we can zoom in, but it says in here that it's high heat stress risk. And so if you had a 43 in this case, you have to take a 45-minute break every hour. So you're only working 15 minutes of every hour. So that's not a very good situation. This is totally fictional. But yeah, it gives you the controls that you need to put in place. You're taking a 45-minute break every hour. You're drinking 1 cup of water. And then you're really monitoring people for symptoms. And then below there, it kind of shows what the forecast is for the next 4 hours. So it looks like it's supposed to go down and you're supposed to get into a yellow zone. So it's supposed to be getting better, which is good. So that's kind of how the tool works. It's an online tool, which is great because all of our supervisors have phones in the field as well. And then they're able to do the on-site measurements. So we did that all last summer. And we did a review after that to see how things were going. And we definitely had some takeaways from that work or that phase. We had a lot of challenges at the beginning of the season with getting accurate readings. So we actually had to do a mid-season crew talk to people to tell them how to do their readings accurately. So like you couldn't have the hygrometer in direct sunlight. It would need to not, because there's fins on the side there. So you're wanting to make sure that those aren't facing the sun. Also, the unit couldn't be like on a table or something because it would get heat from the table. So yeah, there was lots of training on how to hold the hygrometers and take readings. Also, we realized that some of the hygrometers had not been calibrated, so we had to send them out for calibrations for this season. And there's a different calibration for wet bulb, globe thermometer, hygrometers, if you're using that functionality as it is if you're doing the humidex. That was kind of an interesting note for us as well. And then we still have more work to do around medically supervised work. We didn't have to do any shutdowns in 2023. One of the other things we did was review the workload cycle on people. And previously we had considered our staff as doing heavy work, but then when we actually did some workload cycling, we found that they were actually in the moderate workload category. So they were considered at already at a lower heat stress potential. And then finally, one of the challenges that we still have with the app is that it doesn't record the on-site readings. So people have to take the measurements, see what the adjusted humidex value is, and then write it down somewhere else. So from that perspective, it's a duplication of work that we're trying to eliminate in future improvements. So for this year, we are just doing our training right now, which is done this week for my team. We've done those calibrations that I mentioned, and so those are all back out with crews. We've done the training and updates to our work plans and communications. And so we've actually reduced the training time a bit. Last year was like a 3-hour training session, but because we had the training last year, most supervisors are already kind of aware of the tool and the technology and what the plans are. So we were able to reduce that an hour. We did some updates on the heat stress tool just to make it a little more user-friendly. Unfortunately, it still doesn't have that capability to record the temperatures, which is something that we're looking for in future years, but it's generally working pretty well across all of our engineering groups. And we are still doing some work around medically supervised work. we're trying to and maybe you can speak more to that from your organizations, if there's things that you guys do for when you get to those high temperatures and if you shut down or if you do medically supervised work. Oops. So yeah, that is my presentation.
Right, thanks so much. Any questions from the participants? Well, of course, you know, in these spots, we do have a lot of heat, but we are, well, I guess we cope in different ways. But I think the way you systematically have outlined what you do to protect your team from the extreme heat, and of course, in the Caribbean, we too are dealing with matters to do with we seeing the average temperatures increasing, and earlier on we've had some, which also creates problems for the delivery of the water services. But you're taking it from another perspective. I see here we have a comment, I think, from Mr. Gill, so that you wanted to say something here. I'm not losing. Oh, just let me get the chat. Oh no, he was just saying that some of the signs of what are some of the signs of heat stress? I think that was his question.
Yeah, so we'll see people that are kind of normal things where you'll see people slowing down the work that they're able to do. You can sometimes see when you're kind of going from heat stress to heat stroke as well, like people getting clammy skin or disoriented, lightheadedness. So yeah, there's a bunch of different symptoms that we're kind of looking out for with crews to make sure that they're doing okay. When you get up to medically supervised work, you actually have to be measuring biological factors like heart rate as well. So those are kind of when you get up into those high heat zones, things that you need to be looking for.
Right. I think you also noted some of the, I think, special equipment that you have to get for your team, and I think you also mentioned that you have to, well, you monitor the temperatures on the outside.
Mm-hmm.
But yeah, could you give us some, well, if you don't mind, I think there was a particular slide where you were showing some of the average temperatures of near 38 degrees that you had to, that
Yeah,
was
let's see if I can just go back.
stress point.
Let me go back to the slide. So yeah, some of the temperatures, our temperatures are usually kind of lower in the day and max out around kind of more around the 4 p.m. range. So most people are around noon, but yeah, we were kind of getting up into the 30 degrees Celsius temperature range, but then when you added in a humidex with the relative humidity, we were more up in the 40 range. And
Yeah,
sorry,
we have
that's part of your question there. Did I answer?
okay, thanks. Yeah, we have two questions here, I think. Would you recommend that someone that's in the chat room from the Wind Valley, would you recommend someone to operate and supervise the equipment separately on a job site? And two, instead of a crew supervisor?
Right now we have it with the supervisors, but they can assign it to other people because sometimes we do find, which you may see similarly, is that our supervisors are so busy managing a whole bunch of different things that becomes challenging for them to be like looking this up every hour. If there are kind of changes that do happen, we do need to kind of record those changes and what the controls are that we put in place. So it works well with the supervisor so that they're in the know. But yeah, we do switch it up sometimes.
Okay. I'm not seeing any others in the chat room. I guess you were pretty,
Well, hopefully I
Hi.
gave enough information. Oh,
yes,
sorry.
someone is on. Please proceed.
Yes, good afternoon. This is Timothy Augustus, professional operator out of Trinidad and Tobago. And, thank goodness we are now in the rainy season. Up to May, we were in some very high temperatures. And of course, operators, many of them work out in the field and exposed to these high temperatures. And of course, in Trinidad, we had accompanied with that the Sahara dust. So it was a very difficult time to deal with. And it seems to be getting worse. So again, maybe next year it might be higher than 34. So this system that you have there, it is, I think we should adopt something like this in terms of keeping a record of temperatures as we work on the outside so that we can, safeguard our workers, because there are many times that I had to run and sit down in the vehicle. I couldn't take the heat. So, thank you for this, but could you just give me a little more explanation on the wet bulb globe temperature equipment there, and if we can possibly look to source things like this in Trinidad?
Yeah, the wet bulb globe, I'm sorry, I'm just gonna go to it, is it's called it's a Reed R6 6200. And so this is what the device actually looks like. And it can do both wet bulb and the Humidex methods. So you just have to kind of change some settings on it to set it up for both methods. And so yeah, it's got the bulb here that does part of the measurements, and then it does air temperature and a bunch of different pieces to come up with the wet bulb globe temperature reading. And so yeah, I can figure out, I'm not sure, like I'm sure there's lots of different manufacturers for these, but there are lots of different devices. But yeah, I'm happy to share my presentation if people find it helpful. And I can probably send a link to our provincial regulations, because they have a lot of great information as well.
Yeah, you can
Great, thank you.
always share that with me and I will share it with the team, not a problem.
Okay.
Yeah, that was a good observation. Um, about the wet bulb globe temperature instrument. I think there's another question here from Mark Lacan. How much has changed to worksite work time planning help? How much has, yeah.
Yeah, that helps a fair bit. I mentioned, so our regular work hours are 7 to 3:30 for crews. So on really hot days, if we can have us start earlier, we actually have to get a noise variance to start earlier and kind of forecast that in advance, and work with our unions. But if we can have the day start, often with our paving crews, we'll even start at like 4 a.m. To keep people out of the heat. And so, yeah, where we're trying to kind of like shift the work, we also work with our unions on that.
Any other questions, observations? I don't see any others in the, I guess the usual would, you would have your crews to be well hydrated and of course their PPEs intact.
Yes, and on a day where the forecast is hot, we send out a notice at the beginning of the day for to advise that there's a heat notice in effect, and that will include recommendations around what's signs and symptoms to look out for heat stress, making sure that you have your tents and your ice baths and your water. We also will buy additional water for crews and take around crews and recommend they're kind of monitoring each other for any signs of heat stress.
Well,
Yes.
yes,
One
go
more
ahead
thing,
again.
let's say out of Trinidad and Tobago again.
Yes.
in terms of the regulations, in terms of the laws, are they particular to, dealing with heat stress on a legal basis? If companies don't comply, is it that they're going to be fined or charged or taken to court?
Yes, it is. That is the case in British Columbia. We are required to comply with the regulations. And if we are not compliant and something was to happen, the WorkSafe BC can review us and issue orders against us for taking action to address the issues, but it can also escalate up into fines. And it can also, if you were like knowingly took an action that would potentially impact a staff person negatively, you could be personally liable as well.
Great, thank you.
All right, Emmy, I don't see any other questions.
Hi, one comment, Mr. Shaw, doing Valley. Yeah,
no,
doing
the
Valley.
floor is open, so you do ask the questions, yeah.
Okay, great. Afternoon, everyone. Just to make a comment on the importance of it. With regards to Timothy, there's only one time we did a project as a confined space for we decommissioned and we sanitized a STP, and that's in the private sector, and they used a heat monitor. And what happened, they had a specialized person operating the equipment. And just as the young lady said, as far as the hottest times of the day, you had like 45 minutes rest period and 50 minutes. And so we did the work, we did much of the work, barring any permit issues, we did much of the work, like 10 to 12. You had more contact hours. And then let's just say like 4 o'clock to 6, and again we work 7 to 7, so you'll have like 4 p.m. to 7. You'll have more contact time doing more work. I don't know if there's any legal issues as far as in Trinidad. And again, that was a couple of years ago, and we've done work where in the hot sun, but they had safety officers and they had water stations and they had confined space entrance and supervisors just monitoring to see asking a couple questions as much as possible, if the guys are all right and that kind of stuff. So there's only one time, and I like how you have the recording and stuff as far as at least the attempts to record the times and stuff. So they will have the person every half an hour go in, do a heat check. If on the monitor it shows a particular temperature, it will dictate how much persons go in and how long we stay.
Great.
Yes, Timothy, you have, oh, that was Tim, sorry. Yes, I imagine the teams would have to, you would have, I guess, because of the exposure, you probably have to be rotating the teams throughout the day.
Yeah, correct. So we had in that particular project, we had probably like it was 7 to 7. We had it's a 24-hour project, and so we had a couple of guys, probably like 5 or 6 guys, probably like 3 or 4 guys defined, or I should say ready to go in and do any confined space work along with the other aspects. And so the client, they organize for heat monitoring and sulfur, the toxic gases monitoring and oxygen levels and that kind of stuff. So it was pretty intense. So it was, and again, that was the first time seeing other projects. It was like the first, and so it was almost like they were nonchalant about it, saying, well, they were pretty nonchalant, and we did projects after that, and they haven't really, I haven't seen them instituted that heat monitoring system. It was almost like, hey, it's too hot, and we use disposable coveralls on top of regular flame retardant coveralls. So it's pretty intense. So it's an aspect of doing jobs in the Caribbean or hot areas with hot temperatures, it's an aspect that's probably pretty need to be it need to be adhered to. You know, companies should take front and really deal with that, because up until then we were like, okay, you all measure for heat, we didn't know this, you know. So it's a nice presentation, and it's something to really to institute in the planning, on job planning aspects.
Yeah. Yeah, any other comments, observations, questions? Feel free. I think we have someone who has given us a good snapshot of what happens in a situation. Is there a cutoff? Well, if you have is there a certain cutoff temperature? For example, if you go exceed, say, 38 degrees C, would you have to withdraw
Yeah, so
the site at a
here
certain
it
point?
kind of shows if you were doing moderate work and there was no radiant heat impacts, you're doing the humidex method. If you were over a adjusted humidex of 50, only medically supervised work can continue. So, and then I'll just show the slide before. Where is it? This is kind of shows where, and this is in the link that I can show you with the regulations. So if it's 45 or over and you're acclimatized, you have only medically supervised work. If it's 50 or over and you're moderate work, medically supervised work. So yeah, it kind of gives you a whole table of when you would go to medically supervised. And that's kind of the highest threshold. When you're like, previous to that, it's kind of like a 15-minute break an hour, a 30-minute break an hour, a 45-minute break an hour, and then it's only medically supervised beyond that. So this is straight from our regulator, this table.
Right, that's very helpful. If you wouldn't mind as well, because I think I got started on the recording a bit late. If you mind putting up the first slide, which was the topic. Yeah, that helps very much. Yeah, thank you. I needed to capture that for the records, because this is being recorded, so everyone would remember the topic properly.
Well, thank you so much for having me. I have to jump off now because I have another call.
Yes, thank you very much. And we really appreciated you joining us. And we want to thank Valerie Jenkinson, who made the contact for us, but she is attending a conference elsewhere, so she couldn't join us today. But I'm Ignatius Jean, your host at CAWASA, the Caribbean Water and Sewage Association, based in St. Lucia. And every Wednesday we host this webinar series, and today is number 14 in the series. So we thank all of you for joining, and especially Ms. Emmy Sidwell of Vancouver City, who gave us this very important topic, improvements to heat stress plans in engineering services operations. Thank you, Emmy.
Thank you so much. Have a wonderful day.
Thank you, everyone. Goodbye.
Bye.